Okay, now the topic is steam jet refrigeration cycle or known also as vacuum refrigeration. So makikita nyo, ito yung equipment. Ginagamit din to sa mga agricultural, mga sa refrigeration o sa ibang application din. Okay? So dito, makikita nyo sa figure, mayroon converging, diverging nozzle, high pressure motive steam, mixing chamber. So natin to, di ba sa meron tayong condenser evaporator. So itong evaporator, ang ano niya dito is yung chilled water. Itong chilled water, pupunta naman to sa evaporator air. Doon sa cooling coil naman, yung papalamigin naman niya yung air. Okay? So dito naman, so condenser, so this evaporator, so papasok yung chilled water through spray, then papalamigin sa yan. Dito, since namamig to, ito naman, ang vapor. So mainit to, di ba? So mag-exchange, yung malamig, mag-iinit. So magkakaroon siya ng vapor, low pressure. Then meron tayong nozzle, high speed to. So mababacuum niya. So mixing dito, pupunta doon sa condenser. Condenser, magpapalamig naman is cooling water, yung sa cooling tower. Okay, so dito, din magiging condensate siya. So, yung part nito, pupunta doon sa, dito, sa evaporator. Kasi yun ang yung make-up na doon. Kasi ito nga nag-evaporate. So, yan. So, itong yan, saka itong nag-evaporate, itong make-up, saka itong nag-evaporate, same yan. So, itong high pressure, motive steam, yun din yung pupunta sa boiler. Sa boiler, babalik naman siya sa, pupunta sa boiler, sa bubur, gagawing steam ulit. Eh, yun tayong condensate pump. So, yan ang so ito, siyempre may air dyan. So, i-eject niya yan. So, ito yung cycle. Ito yung diagram equipment diagram ng steam jet refrigeration. So, introduction. Na-introduce ko na doon. So, in the steam jet refrigeration, so, tingnan nyo lang yung figure habang nagbabasa ako. Steam jet refrigeration system, water can be used as the refrigerant. Like air, it is perfectly safe. So, air refrigeration kaya na ito naman water. So, pag mga R12 or doon ka sa vapor compression. Kasi may phase change. Ito wala. This system were applied successfully to refrigeration in early years of the century. O last century na. Yeah. At low temperatures, the saturation pressures are low. 0.008129 bar at 4C. And the specific volumes are high, 157.3 cubic meter per kilogram at 4C. So the temperatures that can be attained using water as a refrigerant are not low enough for most refrigeration applications, but are in the range which may satisfy air conditioning, cooling, or chilling requirements. So, hindi masyadong mababa, pero yung iba satisfied naman. Also, this system are used in some chemical industries for several purposes. That is the removal of paraffin wax from lubricating oil. Ayan, nabanagat kanina yung equipment ito. Diba? Sa mga chemical process, agricultural, meron sa mga ganyan, mga equipment, laboratories. Note that steam jet refrigeration are not used when temperatures below 5 degrees are required. Yeah. The main, okay. Okay. The main advantages of the system are the utilization of mostly low-grade energy and relatively small amount of shop work. Here, water is used as the refrigerant and the cooling effect is produced in the steam jet refrigeration continuous cycle by vaporization of a part of water in the evaporator at a low absolute pressure level. Okay? Pag isa mataas ang pressure, isa mababa, nababacuum niya, nahihila niya. So the steam jet refrigeration system, also known as ejector system refrigeration system, is one of the oldest method of producing refrigeration effect. The basic component of this system are an evaporator, a compressor device, a condenser, and a refrigerant control device. Yan. Ito yung basic components. Ang compressor device, ano yun? Dito yung pump. This system employs a steam injector or booster instead of mechanical compressor to compress the refrigerant to the required condenser pressure levels. Ayan, itong system na ito magiging compressor mo. So in the system, water is used as the refrigerant. Since the freezing point of water is 0 C, therefore it cannot be used below applications below applications below 0 C. The steam jet refrigeration system is widely used in food processing plant for pre-cooling of vegetables and concentrating fruit juices, gas plant, paper mills, breweries, etc. So kaya sa agriculture. Yeah? So ito yung principles of steam jet refrigeration system. So ito. Ayan. Okay, paras lang yon. Nag-iba lang yung pagka-drawing, di ba? See? Okay. Paras sa boiler. Paras lang, di ba? The boiling point of a liquid changes with change in external pressure. In normal conditions, pressure exerted on the surface of a liquid is the atmospheric pressure. If this atmospheric pressure is reduced on the surface of a liquid by some means, then the liquid will start boiling at lower temperature because of reduced pressure. This basic principle of boiling of liquid at lower temperature by reducing the pressure on its surface is used in steam jet refrigeration. Ba? Yung mga air conditioning na ano yun, yung walang compressor, yun nga, yung na-invento ngayon. Hindi naman yun na-invento, ito na yun eh. Diba? Ito na rin yun. Nababa lang yung pressure, o sa pressure lang nag-ano yun para makuha mo yung mag-boil. The boiling point of water at the standard atmosphere pressure is of 760 mm of Hg is 100 C. It may be noted that water boils at 12. Okay, hindi ito 12. If the pressure on the surface is kept at 0.014 bar and at 7 C if the pressure on the water surface is 0.01 bar. Okay, tama pala. Mababa yung pressure. The reduced pressure on the surface of water is maintained by throttling the steam through the jets or nozzles. So working of steam jet refrigeration cycle. Same lang yan na same. Steam jet refrigeration system use steam ejectors yan to reduce the pressure in a tank containing the return water from a chilled water system. The steam jet ejector utilizes the energy of fast-moving jet of steam to capture the flash tank vapor and compress it. Flushing a portion of water in the tank reduces the liquid temperature. Figure represent schematic arrangement of steam jet refrigeration system for water cooling. And this system shown high pressure steam expand while flowing through nozzle 1. Ito tayo sa taas. Ito ito baka maano kayo. Okay? Internet yan. Ito yung sa book. The expansion causes a drop in pressure and an enormous increase in velocity. Steam flows through the ejector or sometimes called an inductor or venturi and creates a low pressure zone in the branch nozzle of the ejector. Same topic din sa power plant yung steam, yung jet condenser. Check na yun. The low pressure nozzle is connected to a chamber filled with water. As the pressure continues to reduce in the water-filled chamber, the water begins to boil. This provides the cooling action. So the velocity is gradually reduced in the diffuser, but diffuser, tong part na to, diba venturi yan? But the pressure of the steam at condenser pore is increased 5 to 10 times more than that at the entrance of the diffuser, that is 0.01 bar to 0.07 bar. This pressure value corresponds to a condensing temperature of 40 C. This means that the mixture of high pressure steam and plus vapor may be liquefied in the condenser. So the latent heat of condensation is transferred to the condenser water, which may be at 25 C. Then the condensate pipe is pumped back to the boiler, from which it may begin again be vaporized at high pressure. Sa ibang, di mo makikita yung boiler. Sa ibang makikita mo. Sa first natin, makikita mo walang boiler doon. So sa ibang book, makikita mo na pupunta pala yun sa boiler. Or any means na maibalik niya sa steam. The evaporation of a relatively amount of relatively small amount of water in the flash tank or flash cooler reduces the temperature of the main body of water. The cooled water is then pumped as the refrigeration carrier to the cooling load heat exchanger. Ito. Ito na yung sa air cooler, ganyan. Example of vacuum refrigeration. So, ito yung buong system. Tingnan nyo sa figure niya. In a 10-ton vacuum refrigeration system, warm water at 56 degrees Fahrenheit enters the evaporator wherein the temperature is 44 Fahrenheit. Ito yan. Warm water. Nasaan na yun? Ito yung load. Pumasok dito siya ng 56. Then lumabas siya ng hindi. Ito yung load. Ito pala. 2. Pumasok siya ng 56. Then lumabas siya ng 44 sa 1. What volume of vapor must be removed from the evaporator? Ilan tong i-remove mo dito sa 4? Ito yung 4, di ba? If the makeup water enters 44 Fahrenheit. So, ito yung makeup. So, 44 siya. What volume of if makeup water enters the evaporator at 90 Fahrenheit? So, dalawang temperature. So, hindi siya, depende ka sa available water mo, temperature mo. Letter B, if the steam consumption of the injector is 35 pounds per hour per ton of saturated steam at 100 PSI. Find the BTU input per BTU of refrigeration later. Pag-solve na natin to. So, yan ang mga numbering. This is condensate pump. Given 10 ton vacuum refrigerating capacity. So, this is na makakonvert mo to sa BTU of refrigeration. To, di ba? So dito, steam consumption, 35 pounds per hour per ton. So, makukuha mo yung steam consumption mo, multiply mo ng 10. Okay? 56 Fahrenheit warm water. 44 Fahrenheit cold water and makeup water. If 90 Fahrenheit makeup water, 35 pounds per hour per ton steam consumption. Saturated steam at 100 Fahrenheit. Required is, so hindi ko nalagay, A. Ito. So, B, yan, BTU input per hour of refrigeration. Yung dalawa, A and B. Ilipat yun na lang. Solution. Ayan yung A and B. Okay? QA, so QA is equal to 10 times 12,000 or 120,000 BTU per hour. 10 times, diba? Convert mo sa BTU per hour. So make a heat balance of this one, evaporator. So M times SF2, liquid kasi yan, di ba? Liquid, water. So pwede ka magawang pitag CP, T. Ay, hindi, kasi may vapor ka dito, wag. So X plus XM, ito, is equal to M5. So, M5 to, times SM5. Pumasok siya yung pasok. Then, ito naman, lumabas dito, lumabas din doon yung steam. So, M times SF1, liquid to, times XM, SG4. So, X is the quality of steam. Kaya ito ang original niya. M4 is XM. Kasi, this is the quality. Yung vapor dito ang kinukuha mo yung, kaya X times M, yung amount of vapor. So, yung lumabas doon, yun din yung pumasok. Kaya nag-equal to M5. Okay. Yan, vapor remove. So, yan. Callin mo yung mga properties. So, yan na yung mga T4 is equal to T1 is 44 Fahrenheit. T2 is 56 Fahrenheit. T4 is equal to 44 Fahrenheit or 90 Fahrenheit. Yan. Same temperature T4 and T1, iba lang yung enthalpy. So at state 1, H of F1 is equal to H of F at 44 Fahrenheit or 12.04 BTU per pound. At state 2, H of F2 is equal to HF at 56 Fahrenheit is 24.06 BTU per pound. At state 4, H of G4 is equal to H of G at 44 Fahrenheit is 1080.74 BTU per pound. BG4 is BG at 44 Fahrenheit or 2113.95 cubic feet per pound. Kasi kailangan natin yung vapor remove and cubic feet, di ba ito? Saan yun? Volume. Okay. So, at state 5, with 44 Fahrenheit, SF5 is same 12.04 BTU per pound. At state 5, 90 Fahrenheit, HF5 is 58.02 BTU per pound. Saturated liquid yan, nasa steam tables. So, the M is equal to QA over HF2 minus HF1. Di ba? Ito yung load eh. Ito yung pumasok dyan. So, neglect the pump effect. So, 1 and 2. Ganun na. Q is equal to HF2 minus HF1 is equal to 120,000 over 24.06 minus 12.04 is 9,983.36 pounds per hour. Neglect the pump effect. Kasi negligible dyan. Letter A, what is the volume of vapor at 44 Fahrenheit makeup air? So, sinul mo dito yung mass. So, makukuha mo na yung ibang mass doon. This mass is equal to M then. M2 or M1. So, from this equation, SFX F2 plus X times SF5 is equal to SF1 plus X times SF5. Kinancel ko yung M. Okay? Ito. Yan. Baka may magtaka yan. Ba't nawala yung M? So, X is equal to SF2 minus SF1 over S of D4 minus SF5 is equal to 24.06 minus 12.04 over 1080.74 minus 12.04 is 0.011247. Now, the vapor removed is XM is equal to 0.011247 times 9983.36 is equal to 112.283. So, and cubic feet per minute, this is B is equal to X, mg times BG4. So, yan. So, 112.83 times 2113.95 over 60 kasi CFM tayo. Utang yung ano. Standard units yan. 3,956 is CFM. Now, the volume of vapor at 90 Fahrenheit makeup waters. Yan, ito 44. Ito sa, ano naman. So, substitute mo ang X mo is 0.01175T sa mga iba. So, the vapor removed is 117.334. Also, the vapor removed now in CFM is 4134 CFM. So, a little difference lang yan. Okay? Now, BTU input per BTU of refrigeration. So, meron tayong, di ba? 1 ton. So, at 100 PSI, S sub G is 1187.17. So, delta H is equal to H sub D minus H sub Fi is equal to 1187.17 minus 12.04 is 1175.13 BTU per pound. This is the boiler load. Diba? Lumabas siya is saturated at 100 PSI. Pumasok siya ng SF1. So, yan. Okay? This is 1175.13. Baka na ulit. BTU input per BTU of refrigeration is yan. 35 pounds per hour times 1175.3 BTU per pound divided by 1 ton over 12,000 BTU per hour per ton. 1 ton, ano eh. 1 ton tayo, di ba? Oh, this is 10 ton. Okay. This is 35 pounds per hour per ton. Okay, tama. Ito na yan. Yan, times 1. Okay, tama is 3.423. 427. This is the answer. Take note, SFF1. Itong delta H system pa, pumapasok dito, lalabas siya as HG. HG rin to. So, papasok siya, kasi negligible yung pump from condenser dito. Ano yung minimum? So, ginamit niya is commonly ginagamit dito is yung minimum temperature is yung sa T1. So, SF1. So, actual, pwede mo gamitin ito kung ito nakakonect yun. Kung hindi nakakonect siya dito, so, di ba dati makeup water natin merong 44, iparehas to. So, yun ang minimum temperature. In case na mag-iba to, so hindi ka pwede mataas kumuha dito. So, sa iba ka kumuha ng source. So, hindi, ang gagamitin mo pa rin pala is yung minimum nito SF1. Okay? Yan. Normally, dito sa kumukuha, yung minimum temperature niya is 44. Yung ano yung value nito sa T1. So, this is the end of steam jet refrigeration. Dito yung part niya. Boiler. Iwan ko boiler ba to? The condenser. Ejector, okay. Evaporator, yan. Saan ba to? Ito yata. Ito. Condenser, labo, sa baba. So, bala siya. Okay, thank you.